In this video, we are going to talk about the preliminaries of probability and stochastic process, some basic definitions regarding probability. I am Dr. G. Lavanya, Assistant Professor, Department of Mathematics, presenting this to you. So, what are the basic preliminaries that we need to know? First and foremost is the definition of probability. So, how do you define probability? Probability, in other words, is the occurrence chance of occurrence of an event. So, in other words, probability or chance is used in day to day life when there is uncertainty in occurrence of an event. Okay, so it is taken to be a quantitative measure of certainty. It is a quantitative measure of certainty. Right. Once we talk about probability, before we go into higher level, we should know what is an experiment and what is in general a deterministic experiment and a random experiment. Okay. Experiment is something you perform, and based on what you perform, you get an output or an outcome. Now let us see what is a deterministic experiment. A deterministic experiment is one which will give you an output which you know for sure based on the parameters that you are going to supply for it. That is, in other words, it is an experiment whose outcome or result can be predicted with certainty. It can be predicted with certainty. For example, you can consider any formula. The easiest one is our Ohm's law. So your Ohm's law says I equal to E by R. Once you know the value of E and R, we know for sure I will always be nothing but E by R, and therefore we will be getting the right answer. Now, our interest is not in study of deterministic experiment, but that of a random experiment. So, what is a random experiment? Random experiment, you will know all possible outcomes, but not what exactly would occur. So, an experiment, an experiment whose all possible outcomes, whose all possible outcomes are known, but the outcome of a particular trial or performance of a particular performance of the experiment cannot be predicted. Now, please look at it. For example, let us consider tossing a coin. In particular, tossing an unbiased coin. So, what will be the output? Your output could be a head or tail. So, I cannot tell in my first toss I will always get head. I can only say it could be a head or a tail. That means I know all possible outcomes, but in particular, I do not know what is going to be the exact outcome. So, this is a random experiment. Okay. Next, we move on to describe what is a trial and what is an event. Now, let us consider the same case, that is tossing the coin. Okay, so when we toss a coin, we may get head or tail. Here, our tossing a coin is a trial. The outcome of the trial, the outcome of the trial, that is getting a head or a tail. That is event is called an event. So the outcome of a trial is event. Trial is nothing but performing an experiment exactly once. That is a single performance of an experiment is known as trial. Okay, so now we know what is an experiment, what is a trial, what is event, what is outcome, and we also have seen what is a deterministic experiment and a random experiment. Next, we go on to describe something called as a sample space. The collection of all possible outcomes is known as a sample space. That is, in other words, the totality of the outcome of a random of a random experiment is called sample space Normally it is represented by the capital letter S. So in our case we are considering toss of a coin. So what would be the sample space? My sample space would be equal to head and tail. Suppose I am going to toss two coins. Then my sample space will be I could get either double heads or two tails, or first coin tail followed by head in the second coin, or head in the first coin followed by tail in the second coin. So the sample space contains four elements. Okay. Next we go to describe what is a random variable. We know what is a variable. Variable is something which is subject to time based on certain parameters. So a random variable, I represent it as an RV. A random variable is a function that associates a real number x of s to every element s in the sample space capital S. So capital S is the sample space and your small s are the elements in the sample space. For example, here you see your small s is here, it could be either HH, TT, TH or HT. Your capital S is this entire set. Okay, so S is the sample space corresponding to a random experiment E. Corresponding to a random experiment E. Now let us check into what is a discrete random variable. So random variable is now further classified as discrete and continuous. So what is a discrete random variable? A random variable is said to be a discrete random variable if it assumes only a finite or countably countably infinite values of x. That is, the range space R, that is, the range space R contains finite or countably infinite points. Finite or countably infinite points. Okay, so we will see a small example. Suppose a random experiment consists of drawing four cards four cards from a pack of cards. I hope all of you know a pack of cards contain 52 cards. So the random variable define the random variable. I represent it as small rv, capital X, as the number of aces drawn as the number of aces drawn. So how many aces are there? We know that there are 4 aces in any pack of cards. So what happens to the range space X? Either in my 4 draws I will be positive to get all the 4 as ace, or I may not have one ace, remaining 3 ace, or I may have only 2 aces or only 1 ace or no ace at all, where I am a complete total failure. So the range space will comprise 0, 1, 2, 3 or 4. So this is how you define a range space. Now you see this is finite, and hence this could be a suitable example for your discrete random variable. We will now go a bit deep to discuss some problems on discrete random variables and also further definitions. Okay, so what is meant by a probability function? What is meant by a probability function? We are discussing this with respect to discrete random variable. Okay, so if x is a discrete random variable which can take values x1, comma x2, comma etc., and such that the probability of x equal to xi is equal to small letter pi, then the pi is called the probability function or the probability mass function. It is either called probability function or probability mass function, abbreviated as PMF. It is also known as point probability function. It is also known as point probability function. When is it known as a point probability function? If it satisfies the following. So what is it that it needs to satisfy? If it satisfies certain conditions, number one, we know that probability cannot be negative. So pi greater than equal to 0 for all I. Secondly, we know that the sum of all probabilities is 1. So summation over I pi equal to 1. The collection of pairs xi comma pi the collection of pairs xi comma pi for I equal to 1 comma 2 comma etc. is called the probability distribution is called the probability distribution of the random variable x. Probability distribution of the random variable capital X. Okay, right. Now let us see a small problem based on this. If a random variable X has the following probability distribution, has the following probability distribution, find value of k, find the value of k and probability of x greater than or equal to 3. Now let us look at the table. X is equal to 0, 1, 2, 3 and 4. My probability of x is given to be k, 3k, 5k, 7k and 9k. So when I go for the solution, I first need to find value of k. So how can I do that? I know that summation p of x equal to 1. So add, I will have k plus 3k plus 5k plus 7k plus 9k equal to 1. That is, I will get 25k equal to 1 or my k equal to 1 by 25. Once I get my k value, I have to find probability of x greater than or equal to 3. I know that my probability of x greater than or equal to 3 is nothing but probability of x is equal to 3 plus probability of x equal to 4. My probability of x equal to 3 is 7k and probability of x equal to 4 is 9k, which sums up to 16k. But k equal to 1 by 25, hence this is 16 by 25. So this is the required solution. I hope in this session you would have now got a clear idea of what is probability, what is an event, trial, and also random variables, discrete random variable, and continuous random variable will be discussed in the next following upcoming sessions. I hope this was useful for all of you. Thank you.